Recording in progress.
Hello all. Welcome to the ERC Blitz. It's a 2-hour focus sprint to help reviewers and authors move forward with the ERC proposals, the ERC PRs, which are waiting on the ERC GitHub repository. I'm Pooja Ranjan and I'm joined by Sam Wilson, the editor, and Mercy, reviewer, and many other authors who are here to be a part of this special event. This event is organized in association with ECH Institute and EIPS Insight to support advancing ERC proposals. Well, to provide some more context, the original idea of hosting an ERC Blitz was proposed by our dedicated editor Sam Wilson, who has been consistently supporting the EIP process through weekly office hour and ongoing peer reviews. But with the growing number of contributions, Sam suggested that we should organize this focus sprint to help move things forward more efficiently. I would also like to thank Team Award for creating dashboard to showcase the PR analytics and editors and reviewers leaderboard. So you can also in parallel check out eipsinsight.com/analytics, where this dashboard is specially created for today's event. The refreshing time is, I believe, is about 10 minutes. So every 10 minutes, we can see the refresh and how many PRs gets merged. And last but not least, a special thanks to ECH contributors, Akash for creating memes and promoting this event, Waylene for reaching out to different Telegram group to share this event and reach out to different ERC authors. So for today, our goal is very simple. We would like to work through as many as open PRs and possibly identify what is the blocker. We are joined by some authors who will try to provide feedback and ideally merge the proposal which are ready. So we will start the session with a live PR review. Sam, if you would like to maybe share your screen here. This is issue number 387 on ETH/EIP IP GitHub repository.
Perfect. Yeah. So is my screen share working? I kind of hope
It
so.
is working. Perfect.
Awesome.
We can perhaps start with PR number 930. We are joined by author of this particular PR.
Perfect. Hey, so thanks for coming out. Yeah, like we just said, we're going to try and get through as many of these as possible. If anybody has any specific questions, feel free to just shoot them in the chat or interrupt me. Otherwise, I'm just going to be going through these as quickly as possible. So, yeah. All right. So, splitting and merging of NFTs. Interface for hierarchical NFTs, enabling splitting an NFT and merging multiple NFTs. Perfect. So, all of this looks good. This introduction 721 and 6150. This introduces structured parent and child relationship between NFTs. Okay, good. So your abstract is pretty decent. Let's see. Why do we need this proposal? So the CIP introduces hierarchical NFTs with splitting and merging capabilities, allowing assets to be dynamically restructured. Okay, that all makes sense. So I should probably take a look at 6150 here. 6150. Okay. Oh, I remember this one. Okay. Yes. Permanently assigned to a parent without the ability to restructure ownership. Assets need to be split into smaller independent units. Good. Scenarios were combined. Okay. Fractional share NFTs. else is fine. We can merge this today. Do work on the comments I posted here, but this is great for draft.
Okay. Thank you.
No, thank you.
Good. So next we are joined by offline chain, and I think
This is 897.
Correct. Yes, off-chain labs.
All right, let's go take a look. Okay, a cross-chain broadcasting standard using storage proofs to trustlessly verify state on other rollups. All right. Okay, so trustless cross-chain storage-based message broadcasting for rollups. Okay, wait, trustless cross-chain storage-based message broadcasting for rollups. Okay, that works. A lot of adjectives. So this ERC defines a standardized proposal for cross-rollup message broadcasting and reception via storage proofs. Users can broadcast messages on a source chain. Those messages can then be read by one or many other chains, as long as those chains share a common ancestor chain with the source chain. Okay, the standard enables trustless message passing around across rollups hosted on different rollup architecture stacks. Okay, so this is good. You did a really good job of summarizing what the proposal is going to be. What I think you're kind of missing here is a little bit of technical meat. So should provide. So you can keep it very high level, just like via storage proofs is it like a good start here. Maybe you want to talk about how that actually works, just very, very high level. But again, this is all like, you have a good abstract so far. This isn't going to stop it from merging. So let's go into your motivation here. So the Ethereum ecosystem is experiencing a rapid growth in the number of rollup chains. As the number of chains grows, the experience becomes more fragmented for users, creating a need for a trustless interop between rollup chains. That all makes sense. These rollup chains hosted on different rollup stacks have heterogeneous properties, and as yet there does not exist a simple trustless unified mechanism for sending messages between these diverse chains. Okay. Many classes of applications could benefit from a unified system. Yep. So examples are good. Okay, so detail on okay, so let's go into see how this works. So there's a singleton receiver and broadcaster contract deployed. So are these okay? Deployed to each chain. Broadcasters are responsible for storing messages. Receivers are responsible for verifying proofs. That makes sense. Perfect. So a receiver learns about the contents of a broadcaster on another chain by using storage proofs to unwrap a finalized block hash of the broadcaster's chain. The receiver verifies these finalized block hashes using storage proofs of the canonical bridge. Here's an interlude letter about the contents. Science rollup share common ancestor chain. Okay, so two prominent issues with this approach are that it is inflexible and brittle. In practice, rollups have heterogeneous architectures. They store finalized block hashes in different places in the rollup contracts. Okay. Where'd that go? There it is. Yeah, it's fine. By introducing pointer contracts that allow the rollup chain owners to dynamically update and set finalized block hashes for their contracts. Okay. So this is how the other chains learn about the tip of the broadcasting chain then. Okay. Change must satisfy the following conditions to be compatible with the system. Must store finalized block hashes on the parent chain. Must store parent chain block hashes in the child chain state. Okay, so this is saying the child block hashes have to be in the parent, and this is saying that the parent block hashes have to be in the child. That makes sense. Must be EVM equivalent without one. Okay. Parent deploys copies of many chains that need to behave the same in all of those chains. Okay. Okay, block hash prover pointer slot. Okay, the broadcaster is responsible for storing messages in the state to read receivers and other chains. Calls the broadcaster and its publishers. Okay. Message broadcast. Yep, that makes sense. Broadcast message. Callers should call publishers. Okay, so I am curious as to why this is a rule. So let's see if that appears in the rationale section. Using storage proofs, caching. Okay, so it might be there, but it is not immediately apparent. Okay. Okay, so block hash provers prove a unidirectional link between two chains that have direct access to each other's finalized blocks. The chains in this link are called the home chain and target chain. Okay, since the block hash provers are unidirectional, each type of chain needs to implement two. One whose home is the child chain and the target is the parent chain. One whose home is the parent chain and the target is the child chain. Okay. Block hash provers must ensure they have the same deployed code hash on all chains. Okay. So again, this would be another one that I'd like to know why. But yeah, we'll come back to that too. Okay. So block hash provers after retrieving the block hash of its target chain given its home chain state. Yep. So the home chain state is either given the block hash assume block proof. Okay, verify the block hash of the target chain given the block hash of the home chain and approve. Must result to be called on the home chain. Any necessary input to determine a target chain block hash from the home chain block hash. Okay. Get the block hash of the target chain does so by directly accessing state on the home chain. Okay, so what does directly accessing state on the home chain mean if it's not reading from its own storage?
So an example of that could be like if calling the rollup contract and saying what's the latest block hash, for example. So like
so
that
it can
block
call
hash.
this other contracts. It just doesn't have state itself.
Right. Yeah.
That makes sense. Cool. Okay. Okay, let's here. Okay, so used to get verified target block hashes. Verification logic is immutable. Changes the structure of the home or target chain can break the logic of these provers. A block hash prover pointer is appointed to a block hash prover, which can be updated if the proving logic needs to change. Okay. Okay. The route taken from the local chain plus the address of the remote chain. Okay. The pointer address is used in the route along with the remote address. Okay, to form a remote address ID. IDs dependent on the route will always be relative to a local chain. Okay. Interesting. Exact copies of deployed on non-home chains. When a block hash prover code hash is dereferenced in the pointer, a copy of the block hash prover may be used to execute as logic. Since the pointer references the prover by code hash, a local copy of the prover can be deployed and used to execute specific proving logic. Oh, okay, so the idea is like you can take the prover from one chain and just put it on every other chain.
Right. Exactly.
Yeah.
So like if you had a prover that could take the Ethereum block hash and give you an Arbitrum 1 block hash, you could copy that code to a bunch of different chains. And if you give it an Ethereum block hash on any of these chains, then it'll give you an Arbitrum 1 block hash is kind of the idea.
Okay, that makes sense.
Yeah, and then you string them together and
yeah. So when they call into, so like let's say the prover is allowed to call into other contracts, which is what we talked about earlier, I think. So
yeah.
you also have to copy all of the contracts it calls into onto the target chain?
So that's why there's two functions on the prover. There's get target block hash and verify target block hash. Get target block hash is meant to be called like on the home chain, and it'll only work if you're on the home chain because
I see.
Yeah. And then verify does all the storage proof stuff, and that can work on any chain because it's pure,
okay.
basically.
Yep, that makes sense. Cool. Exact copies of non-home text to receivers, verifying 32-byte message deposited broadcast into the chains. The caller provides the receiver with a route to the remote account and proof to verify the route. Following operation, subscriber calls, passing route. Okay. Okay. Drop was unique. Yeah, so I'm just going to skip that because I won't be able to understand it. Chain upgrades of chain, repurposed. Chain artificial. Okay. Okay, that all looks good. Some nice diagrams. Great. Yeah, this is great for a draft. There we go.
Awesome. Thank you so much for the feedback. I'll
No worries.
go address those things. And yeah, thank you.
Thank you.
We're off to 1029.
That's correct.
All
We are
right.
joined by Dario.
Hey, welcome. Let's go see what's going on here. Universal real world asset interface, a minimal interface for regulated assets. Okay. Okay. So everything else is good there. So the ZIP proposes a universal real world asset standard, a minimal interface for tokens based on common standards like ERC20, ERC20. Okay. All right. So just want to explain what. So okay, and then okay, the tokenization of real-world assets introduces requirements often absent in purely digital assets, such as regulatory compliance checks, nuanced transfer controls, and potential enforcement actions. Okay, existing token standards realize primarily ERC 2721 and lack the inherent structure to address these needs directly within the standard itself. Attempts at defining universal IWR standards is an unnecessary complexity and gas overhead for simple use cases that do not require. Okay, good. This is excellent. You're explaining why you're coming up with this particular proposal. The broad spectrum of WA classes inherently suggests the need to move away from a one-size-fits-all solution. Okay, seek some more defined balance, but defining an essential interface establishes a common ground for interaction regarding compliance and control without it. Yep, good. I like it. Cool. Okay. Good. Function. Okay. So code. Okay. Okay. Token C. Okay. Focus transfer. Okay. So I'm curious. Why does forced transfer need to exist as a separate event compared to just, so wait, is this meant to be added to an ERC 20? Okay, wait, how does that work?
Yeah.
Transfer.
Yeah.
Okay.
Yeah.
Yeah. Okay. Okay. So let's go see in the rationale section. Okay, flexibility. Okay. Yeah, so it doesn't mention it here. So we'll go up here and we'll say, okay, set frozen's call, changing the frozen amount of token ID tokens for user, using the attribute being frozen, the ID of the tokens being frozen. Okay, so this is meant to be applied on top of like 1155 then, because it has token ID. Okay. Error reverted when a user is not allowed to interact, not allowed for interactions. Okay. So if we go down, so set frozen, changes the frozen status. Okay. Get frozen. All right. So who, okay, requires specific authorization. Yeah. So this is an example of something that probably should be specified in the interface because it's an operator or an owner only. I commented on this one before. I feel like I might have. No. Okay. So. Yeah, go ahead. Just feel free to interrupt.
Yeah, no, I think I had the discussion before with Franjo around defining setters on the interface, and the reasoning here is a little bit what you are writing up already, that like an owner or possibly an operator should know how to interact with this. I wonder whether like automated process of protocols that automate things like set frozen might benefit from a standardization of such functionality and those having it in the interface itself.
Okay, so you delegate this kind of thing to some other, like, so you'd create the contract, and let's say there was some registry that it implements, a sanctions list. It would be able to call into all of these contracts. Yeah, that kind of makes sense. Yeah, so if that is the case, then putting that in the rationale would probably be a good idea. Just explaining why set frozen exists. Get frozen. Okay.
All right,
I
thanks.
suppose the downside to that is by having set frozen and get frozen, it requires a particular style of implementation. So like you need to have a frozen counter for each contract or sorry, each user. There might be cases where you dynamically calculate this, or it doesn't necessarily make sense to have like a static frozen amount. But like again, I know nothing about any of this. Perhaps you need the ability to freeze specific amounts of tokens. So yeah, whatever makes sense for your contract. Checks if a transfer is currently possible according to token rules and force validation of the frozen tokens. This may involve checks like allow list, block list, transfer limits, and other policy-defined restrictions. From the address receipt, yep, that makes sense. True if the transfer is allowed, false otherwise. Okay, so oh, okay, and then because yeah, that makes sense. So my thought process there was like, oh, well, why can't you just try the transfer? But then this function lets you check even if you aren't the owner of the tokens, whether a transfer is allowed. So that makes sense. Checked if a specific user is allowed to interact with the token. Yep, that makes sense. Okay. Yeah, so I guess if set frozen is in the interface, then it would probably also make sense to have a setter for allowed and denied. I'm assuming the same kind of automation concerns apply there as well. These function power views in the contract. Okay. May depend on context. Doesn't necessarily the unfrozen amount, which is different than the current balance and the frozen balance. Okay, force transfer, forcing a transfer from to must directly manipulate balances or ownership to transfer the asset from to either by. Okay. Maybe both the standard transfer event and the force transfer can bypass freezing validations. Okay. Go to freeze or unfreeze assets to relock mechanisms. Shouldn't allow freezing more assets than those held by the user. So this is saying like if your balance is 0, you can't freeze 10.
Okay. Yeah. The reason for that is probably you might want to preventively freeze things that don't exist yet, but that's why it should not a must.
That makes sense. Okay. Okay, must implement the necessary functions of the Jefferson base standard. Restrict. Yep. Okay. Okay, so the wording of this is a little odd. So um, okay. Does that make sense? Like you don't want to say that minting must run a particular function. You have to say like you can't mint tokens if it would return false. And the distinction there is like you don't want to require that the function actually be called. Let's say the contract just repeats the if statement in their like okay, that's a good way to put this. It's like you have a mint function and it duplicates the logic that is in is user allowed, but without calling is user allowed. That would be allowed, and let's say it's more gas efficient. Like you don't want to prevent a contract from doing that. So instead of saying actually call the function, you just say has the same behavior as that function.
Makes sense.
Can be used to revert whatever cause return false. This might not be used or might be replaced by more specific. I don't think might is one of the keywords. Yeah, so I think it's so it's may. Can be used for this might not be used by less or more specific errors. Okay. In general, error specificity, meaning that broad errors such as no transfer should be thrown. Do not apply. The same is true for that should be triggered when transfer is attempted from user. Less than or equal to its balance, but greater than its inference. But if the amount is greater than the whole balance unrelated, then more specific errors from the base contract should be used instead. Okay. ERC 20 insufficient balance. Okay, it depends on the essential functions. Okay. Okay, so this is reasonable for rationale, but again, it's describing like broad strokes of the design. You really want to get into like specific decisions you made in the specification section. So like this is fine. Just be aware that people reading this might have questions about certain things in your proposal. Try to anticipate what those questions are and answer them, like specific things. As an example, use what before pool can integrate with. So gives pronouns. Okay, forced transfer, selection forced neutrality, confiscation, revocation, recovery, discretion. Okay, forced. Yep, good. So frozen and one frozen defend freeze. Yep, it's fine. Frozen selected for general applicable, non-fungible. Suggestion insufficient, being similar unavailable. Have the term unavailable, so first more confusing and dramatic. Okay, good. Yeah, that's excellent rationale. The CIP defines new interface, alter existing ones. Okay. Okay. Just gonna not read that. Cool. Okay. Access control for force transfer servers. Security of the mechanism chosen by the implementer to restrict access to these functions is paramount. Unauthorized access could lead to asset theft. Okay. Okay, cool. So just leave these comments here. Yeah, I think if you make the changes while we're still on the call and you come back, just shoot a message and we can re-review it. Otherwise, we'll just leave this here for now.
Thank you, Sam.
Oh, my pleasure.
Sam, I think we are close to an hour, and let's give you 5 minutes break.
Sure.
So, yeah, maybe you can stop sharing and grab a glass of water or something, and then we'll get back with next set of proposals review.
Sounds good.
While people are here, as we have seen that we have completed review of 3 proposals. 2 are already merged, and I think the third is also going to be merged. And it's not so easy to go for a review of a new proposal, new draft. While we appreciate all the work that is being put in by these editors, I would like to take this break to maybe showcase how we are sharing this piece of information with the community. Maybe Vivian, if you could take a couple of minutes to walk us through the dashboard and how people can keep track of their proposals and also follow the progress.
Yes, Pooja. I'm sharing the screen. Yeah, so this is the dashboard that we have designed for keeping track of the reviews, and this will be updated within a few minutes after the review is made, and this will be continuously running. So you can keep track of the progress of the ERC Blitz about the PRs reviewed by the editors. Here are the reviews that are made so far by uh, editors Bowmanats and Sam Wilson, and these are the contributions that they have made. You can also see the closed or merged PRs activity that we are also keeping track over here. So, like for example, Sam Wilson made this I mean made this review, and after that it got merged. And you can also check out the link that we have attached with that, like this. And you can check that in this link, eipacinsight.com/analytics. I have already shared the link, and I am sharing the link again.
Thank you, Vivin. For people who didn't make a note of this, when we started today at 1600 UTC, we had a total of 117 open PRs. We are already down to 115. I hope that we are going to go further down. So we can now move on to the rest of the proposals which are added here. We can go from last call set of proposals. Sam, if you would like to maybe share your screen one more
Yeah.
time.
Absolutely. There. So, last call proposals. 7399. All right. It's failing here. Oh, okay, that makes sense. Cool. Let's give this a read. Flash loans. Interfaces and processes for flash loans. That's not, wait, it's going from draft to last call. That's not a thing.
Yeah, that's a common mistake people do it. So we can use this as a good opportunity to let people know that this is not the process. You have to go through all different statuses.
Yeah. Okay. So interfaces and processes for flash loans. Interfaces and processes for okay.
Sam, I have a point to make here. I'm just trying to understand this. I noticed the title of the proposal is Flash Loan with some kind of emote icon in front of the title. We do have
Yeah.
a proposal number 3156, which is exactly the same, Flash Loans. So will it create any kind of confusion? Should we recommend the author here to maybe use a different title because it's kind of,
That's an excellent point. So would you say it was EIP
5.6?
3196? 5.6. Yeah. Okay.
And I noticed the author name is also Alberto in both the cases. So here I understand it's in the final, it's a final proposal. Alberto could be there, but I'm not sure if it is there. But yeah, my point is if the author is same and the proposal is same, shouldn't it come with a different name in order
It
to avoid
definitely
any
should.
confusion?
Yeah. Okay. Sorry, 1 second. Okay. Leave a comment here. So okay. So flash loan is a loan between a lender and a borrower. Smart contracts must be repaid plus an optional fee before the end of a transaction. Yep, that makes sense. It's not literally. It's very, very close. The ERC specifies interfaces for lenders to accept flash loan requests. Yeah, okay. So why is there another one?
Maybe we can just, if we are very close and we are using some components from the earlier proposal, we can just have it in the required section instead of repeating all over
Yeah.
again.
Okay. The current set of flash loan ecosystem is fragmented and lacks standardization. Okay, I mean, that's different. Good. The absence of a common interface results in increased integration efforts. Yep. Okay, inconsistent syntax. More for this interface. Yeah, so okay. Under the standard, flash loan is loan of an amount of an ERC 20 asset from a lender. This loan can remain open for the span of a single flash call in the lender. This amount plus a fee defined by the lender in the same asset must be repaid before the end of flash call at a repayment receiver address defined by the lender. Cool. Let's pull this open. So backtick should only be used for inline code. So we'll get rid of that. By the lender. So is lender code? Lender must implement the following interface. Not really. Here, let me commit this. Hopefully that doesn't lose my review so far. Okay, good. used for okay. So the flash function is called by the initiator who defines the loan receiver, the callback receiver, the callback function, the asset, and the amount. Okay, when the initiator calls flash in the lender will then transfer the amount of asset to the loan receiver. The lender, after transferring amount of asset to the loan receiver, will execute the callback function. Yep, that makes sense. The lender will include this callback function, call a number of parameters related. Yeah, okay. The amount and fee need to be transferred to a repayment receiver before the end of a flash call. The fee can be set to 0 asset. Okay. So I guess fees are always paid in the same asset that's being loaned. Interesting. The callback function can return any arbitrary data, which will be received by the initiator. Yep, that makes sense. The lender decides which assets to support all possible assets. Okay. Okay, the amount of currency available to be lent. Okay, the fee to be charged for a given loan returns if the loan is not possible. Why? Okay, let's see if that's in rationale. Impossible loan, the lender is not able to serve the loan. Okay. Yeah, that doesn't make sense to me. So, 2 to the 256 minus 1. Okay. Flash fee, initiated flash loan, the loan receipt, callback data, sync code packed is 20 bytes plus 4 bytes. The callback of the return function. This is a combination of the signature of the callback function. So the call data this is just passed literally to the function. Okay, that makes sense. Cool. Max flash loan function must return the maximum available loan for asset. The max flash loan function must not revert. If no flash loans for the specified asset are possible, the return. Yep, that makes sense. The flash fee function must return the fee charged for a loan of amount asset. The flash fee function must not revert. The flash loan specified asset is not possible. Okay. Line 13 should on and okay. Bytes memory callback, the flat. Okay. The flash function must transfer amount of asset to loan receiver before executing the callback code. The flash function must include message sender as the initiator in the callback. Oh, I see. So it passes that through. Okay. The flash function must not modify the asset, amount, and data parameter received, and must pass them on to the callback. Okay. The flash function must include a fee argument in the callback with the fee to pay for the loan on top of the principal, ensuring that fee. Yep. For the end of the callback, the asset balance of the payment receiver must have increased by amount plus fee from, yep, cool. Callback receiver of flash loans must implement one or more external functions with the following requirements. The interface discrepancy receiver. I guess that is there. Have to deal with reverts. Let's go leave a comment on this. Okay, back over here. Flash fee, flash is potential function name of the verb. Okay, that's fine. Essential flash lenders. Yep, that makes sense. Initiator will often be required in the callback function, which lender knows. Okay, a loan receiver is taken as a parameter to allow flexibility on the implementation. Okay, amount will be required. Fee is calculated in the callback. Passing a fee as a parameter. Yep, that makes sense. Arbitrary callback functions. CIP is successor. Okay. Which of the flash loan function reflect the conditions of the flash loan contract, but cannot be trusted unconditionally. They can be divided in two groups that require different checks before they be trusted to be genuine. No argument can be assumed to be genuine without some kind of verification. Initiator, asset, and amount might refer to past transactions. If the caller of the callback. Yeah, okay. To verify the value, to verify the callback caller. The callback caller, that's the lender contract. So it's weird to be switching between names here, but that's okay. Since often the caller flash will also be receiving Okay. Okay, yep. That makes sense. Yep, that all makes sense. Cool. So this is okay to merge, but okay. Cool. So moving on to the next last call. So this is 1064.
And this is one of my favorite one. I know this has been waiting for a very long time. It is SIWE.
Oh, this is signing with Ethereum. Nice. I love this one. Okay. Cool. I don't have to edit it. So that's good. So, sign with Ethereum describes how Ethereum accounts authenticate with off-chain services by signing a standard message format parameters by scope session 2. It's a beautiful abstract. When signing into popular non-blockchain services today, users typically use identity providers that are centralized entities with control over use of identities, large internet companies, email providers. With these parties, signing with Ethereum offers a new self-custodial option for users who wish to assume more control and responsibility over their own digital identity. Already made use of investor signing, such as to establish a cookie-based web session. Perfect. That's awesome. So, sign with Ethereum works as follows. The relaying party generates a sign with Ethereum message and prefixes sign with Ethereum message with blah. It's defined in ERC 191. ERC 191 is up here. Good. The wallet presents user with a structured plain text message or equivalent interface. For sign with Ethereum message with the ERC 191 signed data format. Good. The signature is then presented to the relaying party, which checks the signature's validity and signing with Ethereum message content. The relaying party might further fetch data associated with the Ethereum address, blah, 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 or other data sources that may or may not be permission. Cool. Signing with Ethereum message was, okay, RC20, 5234, can I edit? 5234, expression of that deck, key sensitivity for a string term as per. Okay, so, on line 42, 41, 42, RFC 5234. Let's do it. Since okay. Good. Message fields. Okay. Scheme. Option of the URL scheme of the origin of the request. URI scheme. Domain. Okay. ISO 861 datetime string. ERC 3339, I think. Yes. Okay. Yep. Bash like informal template of the full for does not reflect. Cool. Following. Yep, that's good. Support, explicit scheme. Verification must be used. ERC 1271. 1271. Yes, when performing search verification, yeah, okay. The relaying party or wallet may additionally perform research to be ENS data to improve the user experience. Good. Good. Yeah, this all looks really good. Yep. Yeah, okay, so this is all really good. Key management. Yeah, none of that's changed from the last time I reviewed it, so this seems good. Yeah, so I can approve this, but it's going to require approval from at least one of these people as well.
So if you approve, it would not merge, or would it?
It would not.
Okay. Then perhaps we can leave a note that you need to follow up with those initial authors as well.
UYC. I should grab it from the side. Cool.
It's a good progress in the direction of moving this proposal towards final.
Yeah, yeah. I lost mine. There we go. So that
919.
was, yep, perfect. Decentralized employment database system. This is blockchain. Okay. That didn't. I think you were right. It's really hard to form. Okay. Build a system to record employment history on the blockchain. Let's just approve. Let's get this approved. So 6 should be 24. The records employment history. All right. This ERC provides a decentralized deployment system built on the Ethereum blockchain, the DES. Facilitates the creation and management of companies' records, compliance, and via an escrow mechanism. Can't wait. Dispute resolution. Okay. By leveraging blockchain transparency and immutability, the system operates post-employee testing and prior to the final hiring and contract signing. Employees, businesses, sold token representing their employment history, work before finalizing labor contracts. Yep. Okay. Centralized to pay. Okay. Should put it clear to okay, so we've got all this stuff. Registered company allows you to register a new company on the blockchain. Unique company ID associated. Okay. Okay, wait, is this supposed to be a single contract that does this? I think it is. So multiple company. So why does this need to be a thing? Let that go. Rationale. Using escrow system. Yeah, so it doesn't actually explain that. So and function. Okay. So that's 7750. So I guess we're doing 1060 now. To review. Mud projects. I haven't heard mud in a long time. Moving from draft to review. Okay. This introduces a flexible on-chain storage pattern that organizes data into structured tables that consist of records with fixed key and value schemas similar to a traditional database. Okay, wait. Store table-based introspectable storage. On-chain tables for automatic indexing and introspectable state. Okay, so special on-chain storage pattern, structured tables. Similar. Okay, the storage pattern consists of a unified contract interface data access, compact binary encoding format. So you change the track through standardized events that enable automatic schema aware state replication by often indexers. Yep, cool. Neat. The absence of consistent standards for on-chain data management smart contracts can lead to rigid implementations. Yep, cool. Neat. That's good motivation. All right. So, smart contract. So the store. Smart contract that implements the interface proposed by this ERC and organizes data in tables and emits events for each data operation. Okay. So a table is a storage structure that holds records sharing the same schema. Okay. 32-byte value that uniquely identifies each table within the store. Okay. Chain tables. The types of keys. Okay. All right. Single byte that represents this type of a specific. Okay. Okay. Schema. Fair enough. You're on specification. Okay, cool. Field layout encodes data. Okay. Field limits. Okay. Okay, that's fine. Okay. Example. Okay. All source must implement the following interface. Okay, get repeal these encoding rules. Be used to define record tuple. Such corporations getting. Okay, that makes sense. Store set record. Okay, it's fine. Good requirements. Yeah, that's fine. Yep, all of that seems good. Okay. Okay. Yeah, I mean, that's all pretty good. You're moving into what? Review or last call? Review. All right, so 7813 is done. Great.
So the next is for proposal 4337, but I should let you know that there is another PR 1048. Both are for 4337. And I'm not sure like which one is the most relevant one because it seems like one is for status change and one is for some minor updates.
Okay. So it doesn't look like this one has been changed since I last reviewed it.
Yeah.
Yeah, so we'll just leave this one. And you said the other one was which? 1038?
1048. So my
48.
question is like, could we not move it to review status because this is review status and there could be further iteration if they need to be.
1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. 1038. Let's see what my comments were here. So we can't move it because
I think he has made some edits after your comments, no?
2938.
I mean, I just want to
Yeah,
support
so
the
it
proposal.
does. Yeah, they're still here. So yeah, unfortunately, I don't think we can move this one yet.
Okay, so the next one is 1048.
Okay, so what is this one? Yeah, so what did this one merge? Close. We open. Let's see. Yeah, so this should merge on its own. We'll keep it open, but
Do we need to like close and open? Maybe something is blocking there.
yeah, I just did that. So
Okay, perfect. Yes.
yeah.
Okay.
All right.
So once that is merged, we are still with the open action item for 4337 to move to the review status. Is that correct? Then I can
Yeah,
follow.
exactly.
Okay. I'll follow up with the reviewer and try to not follow up with the author and try to let him know that he needs to do further action.
Yeah, so this seems fine. This is for final or no, this is review. Okay.
Yeah, these are all like miscellaneous, so it's not for final, but small edits here and there. Some of them are also typo, but yeah, smaller edits.
Okay. Perfect. Okay. Oh, so these are all. Okay, wait. Okay, pure scheme, that's good. Okay. Oh, it's just because you're editing the assets. That makes sense. Explicit, that's good. Addresses, that's good. Layer. Address. Okay, yeah, this all looks good. You can go ahead and merge it. So that was 925. 982. Improved ERC response for the 3 magicians. Okay, so why did this not merge? So HTML proofer is failing. Okay, 7710. Okay, so this should just merge now. Yeah, so we'll leave this open and make sure it merges. That was 982, so 991. All right. Update the acronym to avoid negative. So why did this merge? It's failing on EAP validator. So the title is too long. All right. Immutable secure transaction. I don't know how to resolve this in like a nice way. Tamper-proof web immutable secure transaction. Central on CPI in a tamper-proof way. Okay, let's see. I mean, honestly, I don't need to approve this. I can just comment on it. There. It's 991, 991, 1050. Okay. Use interoperable binary addresses, improve attributes. CPR. Change interoperable binary addresses from 1038. Preserve small chains. It's not add hooks. Okay. So why did this not merge? Because it's missing HTML proofer. $79.30, which does not exist. It does not exist. So why are you linking to it? Oh, there's already 79.30. Okay. So Ethereum ERCs 79.30. Okay. So interoperable address, an extensible binary format to refer to an address specific to one chain. Okay. Interoperable address is a binary Did I comment on this already? I did. So let's see what's changed since my last review. Yep. There's your links, good. Okay, so an extension of binary format to refer to an address specific to one chain. Interoperable address is binary format to describe an address with one chain with a companion interoperable name specification for a human readable display. Signed in a manner that allows security to extend it to support. Okay. Okay. Master chain environment encompasses data. Simple address alone is not sufficient to describe a blockchain account since it does not identify which chain. Yep. Selective data. Okay. Okay. Da, 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 da. Yeah, this seems good. What were my complaints last time? Oh, is it that there's a pair of 7828? And then let me guess, that's the one I was looking at before. No, it's not. Okay. Too many tabs open here. Okay, you can be closed. You're still going. 79. Okay. So let's go and look at 7828. 7828. Sorry, 7930. Okay. Okay. All right, so why did I merge this one? Okay. You're still too long? Gotta shave off, what, 4 characters? There. Okay. Throw address names. Okay. Unified format. This is going to draft. Okay. So unified format for accounts that specifies together with the address of the chain where the address lives, the use of human readable chain names, and how they can be resolved to chain identifiers. The use of human readable account names and how they can be resolved to addresses. Okay. The current thousands of LTCs, the same address. This is coin type. We were booked for 2 hours for this, or did we have longer?
We have booked for 2 hours and we have done it pretty much there. So finally, I think we got to merge 8 PRs, which is great because I know most of them proposals were like draft and new proposals, so it took longer than expected. So thank you so much, Sam, for taking
Oh.
out time and reviewing these proposals.
It's my pleasure. Let's schedule another one of these soon.
Sure, yeah.
Yeah.
Yeah, we can plan about it. Maybe in a couple of months, we can have another one. So we get to share this information with people that this is something happening and it's the best place where you can collect all information about any question and maybe able to get your PR merged. Well, thank you everyone who joined today's ERC Blitz. And people who joined or did not join are watching the recording. If your PR didn't get reviewed, don't worry. We will definitely continue to support via GitHub and upcoming EIP editing office hours. Thank you to all our editors and reviewers who are reviewing it asynchronously also. And special shout out to Sam for flagging common issues. I found it very interesting today, the distinction between motivation and rationale. That is common mistake. People put rationale into motivation and vice versa. So please take a look at that clip. If you missed it, you can find it in recording. And if you are someone who is interested in ERC curation or community education or try to share more about these proposals, please reach out to Ethereum Cat Herders. We would love to collaborate. We'll see all of you next week with the editing office hour. Until next time, keep building, keep reviewing, and keep sharing the standards. Thank you everyone for joining us here today.